Okay, so our main goal for today is to discuss about the concept, test of hypothesis, test on two population. Okay, test of hypothesis, test on two population. Remember, to test the hypothesis, we need to follow the 5 procedures. The first one is you need to formulate your null and alternative hypothesis, and then number 2, identify your statistic. Okay. Number 3, compute for your test statistics. Number 4, come up with a decision kung reject ba yung HO or fail to reject. If you are rejecting your HO, meaning you need to accept your HA. Okay? If you fail to reject HO, meaning you need to accept your HO. Okay? And then number 5, you need to come up with a conclusion. Okay? So we need to follow the 5 procedures. So we will be discussing test of hypothesis, test on two populations. Okay, let's continue. Test on a difference on two means. Okay, so mu sub d, you are referring to the difference of two means. That will be mu1 minus mu2, where mu sub I means a mean of the nth population or ith population. The null hypothesis of the difference of two means is mu sub 1 minus mu sub 2 is equal to d sub o. What do you mean by d sub o? D sub o, you're referring to the hypothesized difference between the two population means. Okay? When we say d sub o, you're referring to the hypothesized difference between the two population means. Alternative hypothesis, so same thing that we discussed last time. The only difference is that in last week, we are discussing only one population. In here, we're dealing with the difference of two populations. Okay? So what will be your alternative hypothesis? So number 1, HA, that will be mu1 minus mu2 is not equal to the hypothesized difference of two means. Okay, if your HA is like that, which is not equal to your hypothesized difference of two means, then we need to come up with two-tailed test. If your alternative hypothesis is mu1 minus mu2 greater than d sub o, again when we say d sub o, you're referring to the hypothesized difference of two means, then we will be using one-tailed test. Okay. And then if your alternative hypothesis is mu1 minus mu2 less than the d sub o, or the hypothesized difference of two means, then we will be using one-tailed test. Okay, so try to take note of those in selecting your what particulars or what specific test that will be used. Okay, so if your HA or if your alternative hypothesis is like that, then we need to follow the specific test. Okay, there are two cases. Okay, in difference of two means. The first one is independent sample, and the second one is related or paired samples. Okay, so what is the difference of independent sample and then related or paired samples? Okay, if you want to determine the difference of two means, there are two cases that is involved. The first one is independent sample, and the second is related or paired samples. Okay, when we say independent sample, take note of this. Random samples are taken separately from the two populations. One random sample is taken, but the units are categorized as belong to one population or another. So the example of independent samples are male and female. Okay? Participants are randomly assigned to one of the two treatment conditions. Okay? So these are independent sample. So to come up with independent samples, there are 4 conditions that we need to follow. The first one is different of two population means. Okay? If your standard deviation of the population is given, claim is that the unknown mu1 minus mu2 is equal to the hypothesized value or d sub o. This is tested against this possible alternative hypothesis. Okay, so these are the conditions. Okay, the first condition is difference of two population means if the population standard deviation is known or given. Okay, so your HA must be in the following conditions. If your HA is, number 1, mu1 minus mu2 is not equal to d sub o. Okay, so reject HO if z is less than negative z alpha over 2, or z is greater than z alpha over 2. If your alternative hypothesis is mu1 is given, such as mu1 minus mu2 greater than d sub o, okay, you can reject HO or your null hypothesis if your z value is greater than the z alpha. Okay, and then the third condition, if your alternative hypothesis categorized as mu1 minus mu2 less than the hypothesized difference of two means, which is your d sub o, then you can reject HO if your Z value is less than negative Z alpha. Otherwise, fail to reject HO, meaning you need to accept your HO. If you fail to reject HO, you need to accept your HO. Okay? So when the population variance or variances are known, then we need to use this formula. So Z is equal to the first sample mean minus the second sample mean minus D sub O, all over the square root of the first variance divided by the sample size plus the second variance divided by the second sample size. Okay. Next is the difference of two population means. This time, the standard deviation of the population is unknown, and then the sample size is large. Okay, so that's the second condition. So claim is that the unknown mu sub 1 minus mu sub 2 is equal to a hypothesized value. This is tested against this possible HA. So take note of the following. So your HA is still the same. Okay, and then the condition still the same rin naman. Okay, the only difference is that the formula that we need to use. Again, if your alternative hypothesis is categorized by the following, mu1 minus mu2 is not equal to the D sub O, so to reject HO if your Z value is less than negative Z alpha over 2, or Z value is greater than Z alpha over 2. Another category is if mu sub 1 minus mu sub 2 is greater than D sub O, okay, you can reject HO if your Z value is greater than Z alpha. And then mu1 minus mu sub 2 less than the hypothesized value, you can reject HO if your Z value is less than negative Z alpha, or otherwise fail to reject HO. Okay? When the two variances are known, meaning given, and the sample size are sufficiently large, then we will be using Z is equal to sample mean 1 minus sample mean 2 minus DO all over the square root of the given variances. Okay? Next, the difference of two population means. Okay, unknown standard deviation of population but assumed equal. So in here, if your sample size is lower than 30, okay, we will be using t-value. Kapag higher than or equal to 30, we will be using z-value. So take note of that one. If your sample size is higher than or equal to 30, we will be using z-value. But if your sample size is lower than 30, obviously, we will be using t-value. Okay? So claim is that the unknown mu sub 1 minus mu sub 2 is equal to a hypothesized value, D sub O. This is tested against this possible HA. Okay. So your HA are the following. So mu1 minus mu2 not equal to D sub O. Reject HO if your T value is less than the negative T alpha over 2. Okay. And then your degree of freedom. Of course, if you're solving for the T value, we need to identify the degree of freedom. Okay, your degree of freedom will be n sub 1 plus n sub 2 minus 2. The question is, why is it your degree of freedom is n sub 1 plus n sub 2 minus 2? Because you're dealing with two populations. So to solve for DF or degree of freedom, you need to add the two sample size minus 2. Okay, because you're given two populations, so that will be your DF. Another one, reject HO if T is greater than T alpha over 2 and your DF is n sub 1 plus n sub 2 minus 2. And then next category for alternative hypothesis, if mu1 minus mu2 is greater than D sub O, reject HO if T value is greater than T alpha, if T value is greater than T alpha. And then your DF still the same, n sub 1 plus n sub 2 minus 2. Next category, if your HA or alternative hypothesis is mu1 minus mu2 less than D sub O, reject HO if your T value is less than negative T alpha. And then your degree of freedom, n minus 1 plus n minus 2, n sub 1 plus n sub 2 minus 2. Okay, so that is your degree of freedom. Otherwise, fail to reject HO. Now, when your variances are unknown but assumed equal, we need to apply this formula in determining the t-value. Again, take note of the condition. When your variances, okay, population variances are unknown but assumed equal, you need to determine the t-value using this formula. So t-value is equal to the first sample mean minus the second sample mean minus the hypothesized difference of two means all over the square root of s squared p multiplied by 1 over n sub 1 plus 1 over n sub 2. To solve for s squared p, that will be equal to n sub 1 minus 1 multiplied by the variances of the sample plus n sub 2 minus 1 multiplied by the variances of the sample all over n sub 1 plus n sub 2 minus 2. Okay, then the last condition, okay, difference of two population means this time unknown standard deviation of the population but assumed unequal. Okay, the standard deviation of the population is not given, but assumed unequal. So plain is that the unknown mu sub 1 minus mu sub 2 is equal to hypothesized value of d sub O. This is tested against this possible HA. So take note of the possible alternative hypothesis. Okay, number 1, mu1 minus mu2. For alternative hypothesis, mu1 minus mu2 is not equal to d sub O. Reject HO if t is less than negative t alpha over 2. And your df. Or the other one, t is greater than t alpha over 2, and then df. Okay, yung b referring to df, degree of freedom. And then other possible condition, mu sub 1 for alternative hypothesis, mu sub 1 minus mu sub 2 greater than d sub O. Reject HO if t is greater than t alpha. And then mu 1 minus mu 2 less than d sub O. Reject HO if t is less than negative t alpha. Otherwise, fail to reject HO. Okay? So, if the condition deals with the difference of two population means your population variance is not given, okay, but assumed unequal, we will be using this formula. So when the variances are unknown but assumed unequal, to solve for the t value, so t value is equal to sample mean sub 1 minus sample mean sub 2 minus the d sub O all over the square root of the standard deviation, okay, I mean the variances of the sample. Okay, when we say s squared sub 1, you're referring to the variance of the sample over the sample size, plus the second variance of the sample over the second sample size. Okay, and then v, when we say v, you need that for to determine your degree of freedom. Okay, so that will be variances of the sample, okay, over the sample size plus the variances of the sample divided by the second sample size squared multiplied by n sub 1 minus 1 multiplied by n sub 2 minus 1 all over, okay, the variances of the sample divided by n sub 1 raised to 2 multiplied by n squared minus 1 plus the variances of the sample divided by n sub 2 raised to 2 multiplied by n sub 1 minus 1. Okay, you will be using these formulas if, okay, take note, if the standard deviation of the population is not given but assumed unequal. Okay, so let's proceed now to the given example. Let's start with number 1. A random sample of 100 women, each from the rural and urban areas, showed that the following mean and standard deviation of age in years at their first marriages. Okay, so these are the residents. So we do have rural and then urban. And then the mean, we have 21 and then 23, and then the standard deviation is 4.5 and then 5.1. Okay, the question is, does the data provide an evidence to indicate that the rural women marry earlier than their counterparts in the urban areas? Use a 5% level of significance. Okay, so here we go. So first is, how do we determine, okay, how do we examine the given problem? Of course, in a hypothesis testing, we need to come up with 5 procedures. First procedure, we need to formulate your null and your alternative hypothesis. So that's the first procedure. Okay. So here we go. First procedure, formulate your null and alternative hypothesis. So we have your null hypothesis. So since we're talking about two populations, okay, the difference of two populations. So your null hypothesis will be, okay, first you need to write first the statement before the symbol, okay. So difference of two populations, right? So your statement will be, there is no significant difference. Okay, there's no significant difference. Dot. The data, okay, the data provide an evidence to indicate that the rural women marry earlier than their counterparts in the urban areas. Okay? So that will be your null hypothesis. Okay? Because when we say null hypothesis, meaning unchanged. Okay? Unchanged, meaning no change at all. Okay? So there is no significant difference that the data provide and evidence to indicate that rural women marry earlier than their counterparts in the urban areas. So how do we write the symbol? Okay? So for null hypothesis is always, okay? So since we're talking about difference, okay, between two populations, so we can say that mu1 minus mu2 is equal to d sub O. So that will be your null hypothesis. Okay, mu1 minus mu2 is not, mu1 minus mu2 is equal to d sub O. So that will be your hypothesis. Using null hypothesis and change. Okay, no change at all. Okay, next, what about your alternative hypothesis? Okay, so for alternative hypothesis, okay, in your null hypothesis we use there is no significant difference. For alternative hypothesis, okay, you need to claim that there is a significant difference. Okay. So for alternative hypothesis, your claim as a researcher, there is a significant difference. Okay? There is a significant difference that the data provide and evidence to indicate that the rural women marry earlier than their counterparts in the urban areas. So meaning there's a changes. So what will be your symbol? So mu sub 1 minus mu sub 2 is not equal with your hypothesized difference between two means. Okay? So that will be your HA. Okay? So that will be your HA. Now, so after we formulate the hypothesis, the null and alternative hypothesis, the next procedure is identify what test. Okay? So identify your statistic. So that will be the second procedure. So after we formulate your HO and HA, you need to identify your statistic. Okay? Identify statistic. Okay? It says in the problem, use the 5% level of significance. So 5% level of significance, meaning your alpha is equal to 0.05. Now, going back to your null and alternative hypothesis. Your alternative hypothesis says that mu1 minus mu2 is not equal to your d sub O. So meaning, you will be using what? Two-tailed test or one-tailed test based on your alternative hypothesis. I will be using two-tailed test or one-tailed.
Two-tailed.
Okay, very good. So we will be using two-tailed. Okay, based on your alternative hypothesis, we will be using two-tailed test. Okay. So reject. If it is two-tailed test, reject HO. Okay. If reject HO. Okay. If what? If what, people? Reject HO if what? If Z, since the given problem deals with the 100 of women, each from the different areas, okay? So the sample size is higher than what? Higher than or equal to 30, so we will be using Z value, okay? So first, you need to check muna, ano ba yung sample size given? So if it's higher than or equal to 30, so we will be using Z value. So in this particular, okay, so the population given is 100, so we will be using Z value, okay? So going back, so identify the statistic, so it's 0.05, so it's two-tailed based on your alternative hypothesis, okay? So reject HO daw if Z is less than negative Z alpha over 2, or Z is greater than Z alpha over 2. Okay, so dalawa lang yan. Reject HO if Z is less than negative Z alpha over 2, or Z is greater than Z alpha over 2. But the given alpha is 0.05. Okay? 0.05, that's your alpha, 0.05. We're looking for Z alpha over 2. So how do we determine the Z alpha over 2? Your Z alpha over 2 is the same as, that will be equal to Z 0.05 over 2. Okay? Z alpha over 2 is equal to Z 0.05 over 2. Now, what is 0.05 over 2? That will become Z 0.025. Am I right? Tama ba? Can you see the solution here? Can you see the solution, my dear people? Kita ba? Hello?
Yes.
Okay. So what is your Z 0.025? Get your table.
1.96.
Okay, very good. So 1.96. So that will be 1.96. Okay? But we are using this one. Ito. Okay. So yan, dalawa yan. Okay, to determine. Reject HO if Z is less than negative Z alpha over 2 or Z is greater than Z alpha over 2. Okay? Can still follow? Next. So after we identify the statistic, we can now proceed to computation. Okay? We can now proceed to the computation. Take note of that one, ha? Take note. Okay, so we need to compute now. Okay? So we need to compute. So since the sample size is greater than 100, okay, so we will be using z value. So z value is equal to the mean, the first sample size mean minus the second minus d sub o over the square root of the standard deviation, I mean the variances, okay, the variances of the population over the sample size. Okay, so how do we solve for the z value? So z value is equal to, what's your mean? Mean is 21 minus 23. Okay, of course your hypothesized difference of two means is 0. Wala namang given eh. It's not given. Okay, over the square root of variance. The given problem, the given is a standard deviation. So how do we convert it to variance? Simply, just get the square of your standard deviation. So that will become 4.5 squared over 100, because the sample size is 100, plus 5.1 squared over 100. So what is your z value? So what is your z value? What is your z value? Anyone? What is your z value? You get a calculator? So what is your z value? What is your z value? Anyone, people? What is your z value? Hello? Hello, my dear? Can you get a calculator and then give me the z value? What's your z value? Hello, what is your z value? My dear, can you hear me? Narinig pa ba ako? What is your z value based on the given? Ano yung z value? You get your calculator. What's your z value? 21 minus 23 minus 0 is over the square root of 4.5. Okay. So 4.5 raised to 2 over 100 plus 5.1 raised to 2 over 100. So what is your z value? Ano yung z value nyo? What is your z value? Get a calculator. Give me the z value, people. What's the z value?
2.94.
Okay, negative 2.94. Okay, your z value is negative 2.94. Now, so after we compute, you will come up with the z value, which is negative 2.94. We can now proceed to the fourth procedure, and that will be decision. Okay, so we have decision. Okay, reject HO. Okay, if there are two conditions. Kapag two-tailed test, z is less than negative z alpha over 2. Okay, yan yung first condition kapag two-tailed test. Or z is greater than z alpha over 2. Now, since the given is negative, okay, so pwedeng ito gamitin. Okay, negative yung z value mo eh. Okay, so meaning your negative z alpha over 2 will become negative 1.96. Because your z alpha over 2 is 1.96. Okay, so you will be having negative 1.96. So you need to compare your negative 2.94 to negative 1.96. So therefore, okay, negative 2.94 less than negative 1.96. Is it? Is it true? Negative 2.94 is less than negative 1.96. Is it true? Tama ba yan? Negative 2.94 is less than negative 1.96. So if the conditions like this, okay, if the decision is like this, since your z value is equal to negative 0.94, we can say that negative 2.94 is less than negative 1.96. So that will be your decision. Now, what will be your conclusion? Okay, ano yung decision natin? Do we need to reject HO or fail to reject? Based on this. I-reject ba si HO or fail to reject? Ano magiging decision, people? Reject or fail to reject? Try to examine. Negative 24, negative 2.94, less than negative 1.96. Reject or fail to reject? Na-meet ba yung conditions? Di ba sabi? Reject HO if Z value is less than negative Z alpha over 2. Yun yung condition. Paano i-reject yung HO? So since the Z value is negative 2.94, we can say that negative 2.94 is less than negative 1.96. So meaning, reject HO. Okay? Reject natin yung HO. Kapag ni-reject yung HO, meaning you need to accept your HA. Okay? Kapag ni-reject si HO, accept your HA. So therefore, what will be your conclusion? Ni-reject mo si HO eh. Pag ni-reject mo si HO, ibig sabihin, ina-accept mo si HA. So what will be your conclusion? So what will be your conclusion? So your conclusion, okay, going back to your statements in the first procedure. So reject HO meaning you need to accept your HA. So what will be your HA? Your HA is, there is a significant difference. Okay, there's a significant difference that the data provide an evidence to indicate that the rural women, okay, marry earlier than their counterparts, okay, in the urban areas. Okay? Meaning there is a significant difference that the rural women marry earlier than their counterparts in the urban areas. So that is your conclusion based on your computation. Meron daw significant difference. Okay? Yung mga rural women marry earlier than their counterparts in the urban areas. Now, if that is your conclusion, what do you think are the factors to justify your conclusion? Ano ba yung mga factors? Bakit nga ba? So what are the factors? Why do you think that the rural women marry earlier than the urban areas? What are the factors? Sige nga, can you give me factors? What are those factors? Why do you think so? What are the factors? What are the factors? Can anyone? What are the factors? Ano ba ibig sabihin ng rural? What do you mean by rural? Those are in the countryside, living in the countryside, right? Am I right? Am I right? When we say urban, you're referring to the city. Now, based on the computation that we have, there's a significant difference now. That the rural women marry earlier than their counterparts in the urban areas. Now, since that is your conclusion, of course, you need to justify your conclusion. You will give me factors. So, what are those factors? Bakit nga ba? Can you give me one factor? Why is it? Bakit kaya? Anyone? Ba't mas maagang nag-aasawa, in short? When you're leaving the rural areas. Why? Can you give me one factor? Instead of the city. Can anyone give me one factor? This is the actual research, my dear people. Ano yung factors? Can you give me one factor? There's a lot of factors, right? But I'm asking only one. So what will be the factor? Before we proceed to the second example. Can anyone give me one factor? Hello? Can anyone give me one factor? Hello, people? Still there? Ano kaya yung mga factor na pwede consider? Why do you think that your conclusion is something like that? Ano kaya? Okay, your conclusion is that there's a significant difference. Meaning what? Meaning they are agreeing that tama yung evidence, yung data, na mas maraming nag-aasawa ng bata if you're in rural areas compared to the urban areas. But you need to justify it. Ano yung mga factors kaya? Okay, this is your actual research paper, my dear people. So what are the factors? Ano yung mga factors na you can consider? Anyone? Hello? Hello? Ano yung mga factors na we can consider? What are those factors? Give me one lang, one factor. Bakit kaya? When we say rural areas, meaning countryside, provinces. Okay? Since yung mga women in the city, they are more on career-oriented. Kasi yung mga women sa provinces, they are more on having their own family. Okay? Something like that. But when we are talking about cities, urban areas, okay, most of them, they are focusing on their careers. Okay? On their careers. More on career women. Ang mga city areas. Okay? That's why your conclusion is correct. Okay? That there's a significant difference between the rural women marry earlier than their counterparts in the urban areas. Okay? Next example. Next example, in the Stroop word color test, words that are color names are shown, okay, are shown in a color different from the word, okay. The task is to correctly identify the display color of each word. The time needed to complete the test for 16 individuals after they had consumed alcohol and for 16 other individuals after they had consumed a placebo drink. Flavored to taste as if it is contained alcohol will be compared. Each group was balanced with 8 men and 8 women. Okay? Assuming that the samples are independent and the populations are normally distributed with, okay, there's a condition, okay, with equal variances, okay, equal variances. Test if those who consume alcohol completed the stroke word color test longer compared to those who consumed the placebo. The table shows some summary statistics. Use alpha 5% or 0.05. So, these are the group. So first group alcohol, second group placebo. Sample size 16, both. Sample mean 113.75 for the alcohol group, and then for the placebo group 99.87. And then the standard deviation is 22.64 for the alcohol group and placebo 12.04. Okay, now if you have noticed that the sample size is 16, that is lower than 30, okay? So we will be using T value. Okay, T value. The question is, Miss, what particular condition in the T value we will be using? So going back to the problem, it says that are normally distributed with equal variances. Okay, normally distributed with equal variances. So meaning, so we will be using what? The first condition up to the T, under the T value, this one, okay? Yung the difference of two population means, okay, the standard deviation is unknown but assumed equal, okay? Assumed equal. So we will be using this formula, okay? Yung first condition under the T value. So going back, okay. Okay, so how do we answer this one? First, we need to come up with your null and alternative hypothesis, okay? So you need to identify your HO and HA. So your HO. So since we're talking about difference, okay, difference of two means. So your HO will be, you can use the statement a while ago that there is no significant difference. Okay, there's no significant difference that those who consume alcohol completed the Stroop word color test longer compared to those who consume the placebo. Okay? So your HO will be, there's no significant difference that those who consume alcohol completed the Stroop word color test longer compared to those who consume the placebo. Okay? So what will be your null hypothesis? Okay? In simple. So meaning, there's no change. Okay? Unchanged. So your null hypothesis will be mu1 minus mu2 is equal to D sub O. Okay? As always, your hypothesis is like that. So mu1 minus mu2 is equal to d sub O. Okay? Next, so after we identify your null hypothesis, what will be your HA? Okay? Your HA will be opposite of that one. Meaning your HA, the research prediction, no, there is a significant difference. Sabi ng research. Okay? Sabi niya, okay, that will be your HA, the prediction of the researcher, okay, that there is a significant difference now. Okay? That there is a significant difference that those who consume alcohol completed the Stewart color test longer compared to those who consume the placebo. Okay? So that is your HA. Meron daw pagbabago. Okay? That's the prediction of the researcher. So your symbol will be mu1 minus mu2 longer. Okay? Okay? So mu1 minus mu2 is greater than your hypothesis. Okay? The hypothesized difference. Your hypothesized difference of two means. Okay? So you do have your HO and then HA. So after that, we can now identify your statistic. Okay? So this is your HA. Take note of this one. Okay? This is your HA. So number 2, identify. Okay? So number 2, identify statistic. So since your HA is mu1 minus mu2 greater than d sub O, we can say that, okay, it's a one-tailed test, okay, based on your HA. Okay? So since it's longer, so it will be based on your HA, kung anong test yung gagamitin. So we'll be using one-tailed test. Okay? Given alpha, which is 0.05 or 5%. Okay? Now, it says that reject HO if one-tailed test. Okay? Reject HO daw if your T value is greater than T alpha, okay, with your DF, degree of freedom, n sub 1 plus n sub 2 minus 2. Okay? Means, bakit n sub 1 plus n sub 2 minus 2? Because you're dealing with two populations. Degree of freedom mo, dalawa rin, dalawang sample size. N sub 1 plus n sub 2 minus 2. Okay? So this is your identify statistics. Okay? But, how do we determine this one? So your DF is equal to n sub 1 plus n sub 2 minus 2. So 16 plus 16 minus 2. So 16 plus 16, that is 32 minus 2, so your DF is 30. Okay, 30. Now, what about your T alpha? Miss, how can we identify your T alpha? So get the table, okay, your T table, this one, then look for 0.5, one-tailed. 0.5, one-tailed, and then degree of freedom, which is 30. Okay? Using this table. So, one-tailed, 0.05. Sabi, one-tailed test, 0.05. So, using the T table, yan. Hanapin nyo yung one-tailed, and then 0.05, and then look for 30. Okay? One-tailed, 0.05, and then look for 30. So, the answer will be 1.697. Okay? 1.697. Again, to determine the T alpha, alpha is 0.05 one-tailed. So using the T distribution table, look for one-tailed. Okay? Look for one-tailed. And then 0.05 and then 30. So that will be your T alpha, which is 1.697. Okay? Now, so after we identify these statistics, you can now compute for the T value. We will be using T value because the number of sample size is lower than 30. Okay? So number 3, computation. So solve for T value. Over the square root of s squared p multiplied by 1 over n sub 1 plus 1 over n sub 2. Okay, so this is the formula for the T value. But of course, we need to solve for s squared p. So s squared p, that will be equal to n sub 2 minus 1 multiplied by s squared sub 1 plus n sub 2 minus 1 multiplied by s squared sub 2 over n sub 1 plus n sub 2 minus 2. Okay? So apply the formula in the first condition. Yan. N sub 1 minus 1 multiplied by the variance of the sample size plus n sub 2 minus 1 multiplied by the variance of the sample size over the degree of freedom. N sub 1 plus n sub 2 minus 2. Okay? Okay. So just substitute. So for the t value, so you do have 113.75 minus 99.87 minus 0 over the square root of 328.77 multiplied by 1 over 16 plus 1 over 16. The question is, Miss, how do you get 328.77? This one. Okay? Use the s squared t. Substitute lang. So that will be 16. So to solve for s squared t, substitute lang. So 16 minus 1 multiplied by the standard deviation. So that will be 22.64 squared plus 16 minus 1 multiplied by 12.04 squared over 16 plus 16 minus 2. So you do have 328.77. Okay? 328.77. So can you please check? Please check nga kung 328.77. Can you please check? Is it correct? But check nga. If it's 328.77. Can you please check? Anyone? Please check. Can anyone check it? Kung tama nga. 16 plus 16 minus 2. Can you please check? Okay, very good. Okay, so that will be 328.77. Now, so after we solve for s squared t, which is 328.77, we can now solve for the t value. Okay? We can now solve for the t value. Kasi nakuha na si s squared t eh. Solve for the t value now. So, substitute. So, your t value will be the first mean, 113.75, minus the second mean, 99.87, minus 0, all over the square root of 328.77 multiplied by 1 over 16 plus 1 over 16. So, what is your t value? Ano yung t value natin? What is your t value? What is your t value? 113.77? Yes.
2.17.
Okay, very good. So that will be 2.17. Okay, 2.17. Now, so after we compute, we can now make a decision. Okay? So decision na tayo. Decision. So decision na. Decision. Reject HO if what? Di ba sinasabi? If T value is greater than T alpha. Okay? T value is greater than T alpha. Remember that our T value is 2.17. Okay? Since the T value is 2.17, is it greater than greater than 1.697? So what will be your decision? Do we need to reject or fail to reject?
Reject, please.
Okay. So reject HO. Okay? Reject HO. Kasi mas malaki yung T alpha natin. 2.17 is greater than 1.697. So we need to reject HO. So if you're rejecting HO, what will be your conclusion? So ano conclusion natin? So what will be your conclusion? If you're rejecting HO, meaning you need to accept your HA, that there is a significant difference. Okay? There's a significant difference that those who consumed alcohol, okay, completed the Stroop word test, color test, longer compared to those consumed placebo. Okay? So that would be your conclusion. Okay? That there is a significant difference. That those who consume alcohol completed the Stroop word test longer, okay, compared to those who consume placebo. So that will be your conclusion. Okay? Next. So we're done with case 1, which is independent. Case number 2 will be related or paired sample. Okay? So ano ba ibig sabihin ng related or paired sample? When we say related or paired sample, each person or unit is measured twice under different conditions. Okay, under different conditions. For example, of paired and related, let's say you do have 8 students and you want to measure their weight after they do have physical activities. So your related example is like that. So you need to compare yung after and before. Okay, after, okay, before and after. Okay, so ano muna yung weight nila? Before, yung original weight nila, that's before, and then then they will come up with different physical activities. So what will be their weight after that activities? So that is paired sample. Okay, you're using only one respondent, one group. Okay, one group lang. Pero you do have 2 conditions or 2 experiment. Okay, so pwede namang pre-test or post-test. So that is related sample. Okay, so related or paired sample, each person or unit is measured twice under the different conditions. Similar individuals or units are paired prior to an experimenting where each member of a pair receives different treatment. So yun. That's the example of related or paired example. Pre-test, post-test, before, after, ano ba ba? What else? What else? Meron ka, let's say for example, you do have one experiment and you will take it in the same day, okay, same time, so something like that, okay, as long as you do have one group of respondents, but you do have 2 conditions, 2 different conditions, okay. So what are the, so if you're talking about paired or related sample, okay, the condition is that the difference of two means related or paired sample, assume that related samples are taken from populations with size n sub 1 and n sub 2 respectively. Assume further that the related samples have differences that come up from a normal population. Okay? Case 2, related or paired sample, data points d sub 1, d sub 2 up to d sub n. Okay, when we say d sub 1, d sub 2, you're referring to the difference. Okay, where d sub I, difference between each pair of the observation. Okay, yung sasabing d sub 1, d sub 2, you are referring to the difference. Okay, so the difference of 2 population means related sample. This is the formula. Claim is that the unknown mu sub 1 minus mu sub 2 is equal to the hypothesized value of d sub O. This is tested against this possible HA. So this is your possible HA. If your HA is mu1 minus mu2 is not equal to d sub O, reject HO if the t value is less than the negative t alpha. Okay, and then your degree of freedom will be n minus 1. Okay, Miss, bakit naging n minus 1 na lang? In our previous topic, it should be n sub 1 plus n sub 2 minus 2. Now, if we're talking about related sample, you only have one group of sample. Okay, in our previous topic, okay, a while ago, meron kang 2 samples. Dito, isang sample lang, isang group lang. Okay, in our previous discussion, a while ago, meron kang 2 groups. When we say related sample, you only have one group. Okay? Pero yung one group na yon, meron silang gagawin 2 activities. Okay? That's why your degree of freedom will be n minus 1. Okay? And then t value is greater than t alpha over 2 n minus 1. Okay? N minus 1, that is your degree of freedom. And then another possible HA, mu1 minus mu2 is greater than d sub O. Reject HO if t is greater than t alpha with a degree freedom of n minus 1. And then the other one, possible HA, mu1 minus mu2 less than d sub O. Reject HO if t is less than negative t alpha with a degree freedom of n minus 1. Otherwise, fail to reject HO. So the formula, if you're talking about related samples, okay, where d bar, ano ibig sabihin d bar? D bar is the average, okay? The average difference of the 2 experiment or 2 conditions. Okay? The average difference of 2 conditions. And SD, you're referring to, S sub D, you're referring to the standard deviation of the difference. Okay? Of the difference. Okay? Of each pair. The standard deviation of the difference of each pair. So the formula for the T value is equal to the difference, the mean difference, yung D bar, we call it the mean difference. Or the average difference, or the mean difference, minus the hypothesized value over the standard deviation of the mean difference all over the square root of n. Okay? So how do we solve that? Okay. Let's say this one, example. Okay. A nutritionist claims that individuals tend to report decreasing dietary intake, the more they are interviewed. To investigate this claim, a random sample of 8 female university students was asked to record their dietary intake for 2 consecutive days. Okay? An analysis on their total dietary intake gave the following results. Okay? So meron ka daw 8 students. So you only have one group, which is 8 female students. Okay? But you need to come up with 2 experiments or 2 conditions. So they need to determine the dietary intake in the first day and then the second day. Okay? Assume that the differences in total dietary intake are normally distributed. So using the 5% level of significance, test the claim that the higher dietary intake is observed on the day 1. Okay? So test the claim that the higher dietary intake is observed on day 1. So what would be your null hypothesis in that particular example? What would be your null hypothesis? So when you say null hypothesis, meaning no change at all. Okay? Laging ganon, walang pagbabago. Unchanged statement. Okay? So your null hypothesis would be, there is no significant difference. There's no significant difference. Dot, ano ba yung claim na test? Dot, a higher dietary intake is observed on day 1. Okay? So there's no significant difference that dietary intake will be observed on day 1. Okay? Wala daw significant difference. So meaning, unchanged statement. So that would be mu1 minus mu2 is equal to these above. Okay? As always, that's your hypothesis, null hypothesis. Next, what about your HA? Your HA will be what? What is your HA? Your HA will be, there is. Okay? Okay? Sabi ng researcher, ang kiniklaim niya, na there is a significant difference that the higher dietary intake is observed on day 1. Okay? Sabi ni researcher, hindi, merong significant difference. Na that the higher dietary intake is observed on day 1. Okay? So that will be mu1 minus mu sub 2 greater than d sub o. Okay? So that will be your HA, that there is a significant difference. Okay, so how do we answer this one? So first we need to determine the differences, yung D. Okay? First we need to identify the statistic. Okay, identify the statistic. So since your HA is mu1 minus mu2 greater than d sub o, so that would be one-tailed test. Okay, one-tailed test. So reject HO if T is greater than T alpha with a degree of freedom n minus 1. Okay, n minus 1 here is your degree of freedom. N minus 1 is your degree of freedom. Okay, so T is greater than T alpha, so the degree of freedom is n minus 1. Okay? So your degree of freedom will be 8 minus 1, so that will become 7. Okay? So what will be your T alpha? Ano ba sabi? Use 0.05 or 5%. Okay? 0.05, one-tailed, and then 7. Okay, same thing. So ito ulit. Yung T distribution table. Look for one-tailed, and then 0.05, and then 7. Okay? So meaning, your T alpha is 1.895. Okay? Look for 0.05, one tail in your T distribution, and then 7. So your T alpha is 1.895. Okay? So next, so we need to solve now. Compute. Okay? Computation. So to solve for T, for T value, the formula is the mean difference minus d sub o over the standard deviation over n. Square root of n. Okay? So what would be your mean difference? So your mean difference is, you subtract each. So 105 minus 1658, the answer is 247 plus 2,237 minus 1,479, that will become 758 plus, so repeat the process, 1,863 minus 1,100, so you do have 763. Okay, and then so on and then so forth. So we have plus 175 plus 212 plus 331 plus negative 221 plus negative 719 all over n, which is 8. So your mean difference is 193.25. So that's your mean difference, 193.25. Now, Miss, what about the standard deviation? To solve for the standard deviation, okay, to solve for the standard deviation, you need to subtract the mean difference, okay, the difference to your mean difference, meaning 247 minus 193.25 squared plus 758 minus 193.25 squared, and then so on and so forth, divided by n minus 1, which is 7. Okay? So to solve for the standard deviation of this one, okay, get the summation of the, that will be the square root, okay, the square root of difference minus the mean difference squared, plus so on and so forth, divided by n minus 1. So that will be the standard deviation of your difference. Okay? The difference nung dalawa, nung day 1 and day 2, minus the mean difference, which is 193.25, then squared, plus so on and so forth, all over n minus 1. So that will be your standard deviation of the difference. So your SD will be 488.42. So that is your standard deviation. Okay? S sub D, the standard deviation of the difference. Okay? So the standard deviation is 488.42. How do you get that? This is the formula. D minus the difference of the mean difference squared plus and so on and so forth all over n minus 1. Meaning, yung difference nung day 1 and day 2, which is 247, minus the mean difference, which is 193.25, okay, squared plus so on and so forth all over n minus 1, which is 8 minus 1 is equal to 7. So your standard deviation of the difference is 482. Now, so since you already have the mean difference and then the standard deviation of the difference, we can now solve for the t-value. Okay? So t-value, so you do have 193.25 minus 0 over 488.42 over the square root of 8. Okay? Over the square root of 8. So your t-value will be 1.12. So your t-value is 1.12. Okay? So after we compute and find out that the t-value is 1.12, we can now come up with a decision. So decision na. Okay? You said that if t is greater than t alpha, you need to reject your HO. But your t-value, since your t-value is 1.12 and your t alpha is 1.895, okay? So kailangan daw t is greater than t alpha. So in this case, less than. So kapag less than, it's not parallel with the condition. Now you can only reject HO if t value is greater than t alpha. So in this, hindi less than siya compared to the t value. So you cannot reject HO. So you need to fail to reject HO, meaning you need to accept your HO. That there is no, so your conclusion, okay, ito na yung decision mo fail to reject HO, that's your decision. So your conclusion is, there is no significant difference, okay? So there's no significant difference, okay, between the two means of a certain group, that the higher dietary intake is observed on day 1. Okay, there's no significant difference between the day 1 and day 2 test, that the higher dietary intake is observed on day 1. Okay, wala daw, there's no significant difference. So that will be your conclusion. Okay, next, test on difference on two population proportion. Okay, hypothesis test about p sub 1 minus p sub 2. Claim is that the unknown p sub 1 minus p sub 2 is equal to the hypothesized value d sub 2. This tested against the possible HA. Okay, your null hypothesis still the same. P sub 1 minus P sub 2 is equal to D sub O. That's your null hypothesis. Okay? And then your possible HA, P sub 1 minus P sub 2 is not, P sub 2 is not equal to D sub O. Reject HO if Z is less than negative Z alpha or C is greater than Z alpha over 2. Okay? And then P sub 1 minus P sub 2 greater than D sub O. Z is greater than Z alpha. And then P sub 1 minus P sub 2 less than D sub O. reject HO if Z is less than negative Z alpha. Otherwise, fail to reject. Okay? When the sample size are sufficiently large, then we can solve it using P hat 1 minus P hat 2 all over the square root of P hat multiplied by Q hat multiplied by 1 over N sub 1 plus 1 over N sub 2. Okay? So that is the formula for Z. Okay? In terms of population proportion. Okay? Example, random sample of 125 hypertensive and 150 normal senior citizens were asked if they read the nutrition levels on food products. Okay, results are presented below. So we have health status, so we have hypertensive, normal, and then total. So there are 35 who said yes, and normal who said 38. The total is 73. And then for those who said no, you do have 90, and then normal 112. Okay, so the total for hypertensive, there are 125 senior citizens with hypertensive, and then there are 150 normal senior citizens. Okay, so the total is 275. Okay, so in this particular table, it says that is there an evidence of significant difference between the proportion of hypertensive and normal senior citizens who read the nutrition levels? Okay, use the 5% level of significance. So we need to determine the significant difference between the proportion of hypertensive and normal senior citizen who read the nutrition level. So for the hypertensive, there are 35 who read, and then for the normal, there are 38 out of 150. Okay. So first and foremost, we need to determine the HO or the null hypothesis, and then HA. So obviously your HO, okay, an unchanged statement. So there is no significant difference between the proportion of hypertensive and normal senior citizen who read nutrition labels. Okay, so that will be new. That would be since we're talking about population proportion. So P1 minus P2 is equal to D sub O. So that is your null hypothesis. Okay, obviously your HA, meaning there's a change, meaning there is a significant. Okay, there is a significant difference between the proportion of hypertensive and normal senior citizen who read the nutrition label. So that will be P sub 1 minus P sub 2. Okay, it's not equal to D sub O. Okay, so P1 minus P sub 2 is not equal to D sub O. So there is a significant difference between the proportion of hypertensive and normal senior citizen who read the nutrition level. Okay, so since our HA is P sub 1 minus P sub 2 is not equal to D sub O, so to identify the statistics, so going back to the table, so we will be using the two-tailed test. Okay, so identify. So number 2, identify statistic. So we will be using two-tailed test. Okay, because of your HA. Your HA is P sub 1 minus P sub 2 is not equal to D sub O. Okay, so two-tailed test. So we will be using 0.05. Okay, 0.05. That will be your alpha. Remember, reject HO if, okay, there are two conditions. If it is a two-tailed test, okay, if Z is less than negative Z alpha over 2, and then the other one is Z is greater than Z alpha over 2. Okay, it is a two-tailed test. Okay, so let's proceed now to the computation. So the computation on determining the difference of the two population proportion. So we have computation. So Z is equal to P hat sub 1 minus P hat sub 2 minus 0. Okay. P hat, based on the formula, so P hat sub 1 minus P hat sub 2. Okay. Over the square root of P hat multiplied by Q hat multiplied by 1 over N sub 1 plus 1 over N sub 2. Okay, so how do we solve this one? Okay, so to solve it is, so your P hat sub 1, okay, according to the table, your P hat sub 1, okay, you need to determine the difference, okay, the difference between the hypertensive and the normal senior citizens who asked to read the nutrition levels. Okay? So your pH sub 1 will be 35 out of 125. So pH sub 1 that will be 35 because there are 35 who read the nutrition level out of 125. And then your pH sub 2, there are 38 out of 150 who read the nutrition level. Okay? So to solve for the z value, so 35 over 125, you have 0.28. And then 38 over 150, you got 0.25. Okay? And then obviously your Q hat sub 1, that will be 0.72. And then Q hat sub 2, that will be set 0.75. So how do you get that? So 1 minus 0.28, you do a 0.72. And then 1 minus 0.25, you do a 0.75. Now to solve for the z value, okay, in terms of a population proportion, so you have 0.28 minus 0.25 over the square root of 0.28 multiplied by 0.72 over 125 plus 0.25 multiplied by 0.75 over 150. So that will be your z value. So using the calculator, you can input everything. Okay. So we have 0.28 minus 0.25 divided by the square root of 0.28 multiplied by 0.72 over 125 plus 0.25 times 0.75 multiplied over 150. Okay. So the answer is 0.56. So your C value is 0.56. Okay, your C value is 0.56. Now, so after we determine the Z value, which is 0.56, we can now come up with a decision. Okay, so for decision, okay, there are two conditions. It is a two-stage test. It says that if Z is less than negative Z alpha over 2, or Z is greater than Z alpha over 2. Okay, if you come up with this decision, you need to reject your HO. Okay, but remember your Z alpha over 2, that will be a Z 0.05 over 2, that will be equal to Z 0.025. So therefore, your Z alpha, diba? Your Z alpha over 2 will become 1.96 based on the table that you have, 1.96. So that's your Z alpha, 1.96. Now, since the Z value is equal to 0.56, okay, 0.56, what have you noticed? Your Z value is 0.56, and then your Z alpha over 2 is 1.96. So therefore, 0.56, okay, is less than 1.96. Okay, 0.56 is less than 1.96. Okay, so 0.56 is less than 1.96. So meaning you need to fail to reject your HO. Okay, 0.56 is less than 1.96. You can only reject HO if Z, okay, Z value is less than negative Z alpha over 2, or Z is greater than Z alpha over 2. So in here, 0.56 is less than 1.96, so fail to reject HO. So therefore, what will be your conclusion? So your conclusion, okay, so since you fail to reject HO, meaning you need to accept, okay, you need to accept your HO. So therefore, there is no, okay, there's no significant difference between, so there's no significant difference between the proportion of hypertensive and normal senior citizen who read the nutrition level. Okay? So there's no significant difference between the proportion of the hypertensive and normal senior citizen who read the nutrition level based on your computation. Again, if you fail to reject HO, meaning you need to accept your HO. If you reject HO, meaning you need to accept your HA. So that's it. Okay, so that's how we compute for the difference of two means. Okay.